The given is line MS is congruent to line RQ, and line MS is parallel to line RQ. We have to prove that triangle MSP is congruent to triangle RQP. The first step, we write down the given and the reason is given. Second step, convert line MS is congruent to line PQ into MS is equal to PQ, and the reason, definition of congruence. Third step, as you can see, angle S is congruent to angle Q, and we know this because of the alternative interior angles theorem. The fourth step, angle MPS is congruent to angle RPQ because of the vertical angles theorem. And the last step, since we know that MS is congruent to PQ and angle S is congruent to angle Q, and angle MPS is congruent to angle RPQ, then we know that triangle MSP is congruent to triangle RQP because of the angle-angle side theorem.
The statement is the segments joining the base vertices to the midpoints of the legs of an isosceles triangle are congruent. So we convert it into given, which is triangle ABC is isosceles triangle, point D is the midpoint of AB, point E is the midpoint of BC, and prove that line AE is congruent to line CD.
Step 1. Draw a picture and graph the midpoints. Then you see the given is the triangle ABC is isosceles. Point D is the midpoint of AB, point E is the midpoint of BC, and we have to prove the line AE is congruent to the line CD. Next, we are going to use the distance formula to find the distance of AE and CD to solve the problem. The distance formula is the square root of y2 minus y1 squared parentheses plus x squared x2 minus x1 squared parentheses. Plug the points into the distance formula for AE, and you will get 0 minus 3a squared parentheses plus 0 minus b parentheses. That equals to negative 3a squared plus negative b squared. In the end, you get the square root of 9a squared plus b squared. Plug the points into the distance formula for CD, and you will get the square root of 4a minus a squared parentheses plus 0 minus b squared parentheses. That equals to the square root of 3a squared plus negative b squared, the end result of 9a squared plus b squared. Since both of the lines are equal in length, we can say that line AE is congruent to line CD.
These are the coordinates for two triangles. We are supposed to identify the transformation of triangle MPR and triangle TVS. We solve it by proving that they are congruent. First step, we need to graph the coordinates. Second step, we're using the distance formula again. We're going to find the distance of the sides of triangle MPR first. MP equals the square root of negative 7 minus negative 7 squared plus negative 7 minus negative 1 squared, which equals 6. PR equals the square root of negative 1 minus negative 7 squared plus negative 4 minus negative 7 squared, which equals the square root of 45. MR equals the square root of negative 1 minus negative 7 squared plus negative 4 minus negative 1 squared, which equals the square root of 45. Then we're going to find the distance of the sides of triangle TVS. ST equals the square root of 7 minus 1 squared plus negative 1 minus negative 4 squared, which equals the square root of 45. TV equals the square root of 7 minus 7 squared plus negative 7 minus negative 1 squared, which equals 6. SV equals the square root of 7 minus 1 squared plus negative 7 minus negative 4 squared, which equals the square root of 45. In triangle MPR, MP equals 6, PR equals the square root of 45, and MP equals the square root of 45. In triangle TVS, ST equals the square root of 45, TV equals 6, and SV equals the square root of 45. They're congruent because of the side-side-side theorem. Therefore, triangle TVS is the reflection of triangle MPR.